Here's section 3.2 part 2, which is really just more of the same from part 1. It's not really any different. Some different types of problems is all. So in example 1, this is kind of a famous type of problem. Famous meaning that it comes up a lot. But we've got a chemist who needs to mix two solutions together that have a certain concentration. So we have a 10% solution, and that could be like 10% sodium or 10% of some type of chemical, basically. So a 10% solution with a 25% solution to get 10 gallons of a new 22% solution. It asks us how many gallons of each solution should we use. So if we look at this chart, which is going to help us come up with our system of equations, we don't know the amount of 10% solution. We don't know the amount of 25% solution, but we do know that we want to end up with 10 gallons when all is said and done as a 22% solution, or mixture. And then for our percent, what we need to do is just, let's change these to decimals. So 10% is 0.10, 25 is 0.25, and 22 would be 0.22. For our total then, we would say x times 0.10 is 0.1x. For our 25% solution, we'd say 0.25 times y. But then 10 times 0.22 is going to go in our last row, so I'm going to change it to 0.22 times 10. And that equals 2.2, because we can actually figure out what that was. So the way I set this up, the better headings here would be like, I think this would be switched, I guess, total and then amount. So I kind of switched those ideas around, and you could have just put them in different order in your table. But if you just can come up with this, here is one of our equations, here's the other one, and so x plus y equals 10, and then 0.1x plus 0.25y equals, we don't want to put the 0.22 times 10, we want to put 2.2. And now what we can do is we can solve this. We could do elimination, and we could actually figure out, if you realize that 0.1 is like a tenth, and that to get rid of a tenth, we would multiply by 10. We'd realize maybe that we could eliminate really quickly here by multiplying by a negative 10. So that gives us a negative 1x. Negative, we're moving the decimal one place, negative 2.5y equals, we're moving the decimal one place, so that should be negative 22, because this is 2.2. So this equation in the middle goes away. What we're doing is adding up the first and the last equation. So our x's cancel out. 1y minus 2.5y is negative 1.5y, which if you're not good at that in your head, you can easily put that in the calculator. 10 minus 22 is negative 12. And if I divide that, I end up with 8. So y equals 8. That means that we would have 8 gallons of the 25% solution. And then we plug this back in, and we'll find out what x is. So x plus 8 equals 10 minus 8. X equals 2, and so that's 2 gallons of the 10% solution. Example 2. This is also another kind of famous staple problem where you've got a jar of coins, or it could be talking about a purse or a wallet or whatever, and they tell you how many coins they have and what kind of coins, and you have to figure out how many of each type there are. So I would like, anytime we can define variables as something other than x and y, where it would be helpful to use a different letter, like in this case, if we're talking about number of quarters, why not label the number of quarters as Q and the number of dimes as D? And then whenever you solve for Q, you know you're talking about quarters. When you solve for D, you know you're solving about dimes, or talking about dimes. So when we set up our equations, then we have, and this happens a lot, we have a quantity equation, which is just you have Q quarters, you add to that D dimes, and you end up with 35 coins. Like however many quarters you have plus however many dimes you have to add up to be 35. Then your other equation is going to talk about value. And so we have to use our own prior knowledge for this, because we all hopefully know how much a quarter is worth. It's worth 25 cents. So we would say 0.25 times Q plus a dime is worth 10 cents, so that's 0.10 D. That has to add up to be the value they told us in the problem, which is 6.95. Now we've got our system of equations. And so I would like to go ahead and use substitution on this one, because I can subtract the D over to the right side and get a new equation, Q equals 35 minus D. And then I can plug this in to the Q right here in the second equation. And I'm doing substitution not because it's necessarily easier, but just to remind us what substitution looks like. Although it can be a little easier when we're dealing with decimals to go ahead and use substitution. So what I need to do is take that 0.25 and distribute. 8.75 is 0.25 times 35. 0.25 times negative D is negative 0.25 D. Then I've got 0.1, and I don't really need that 0 there, so 0.1 D equals 6.95. And then I've got like terms. I can subtract the 8.75 over to this other side. So the like terms here, negative 0.25 plus 0.1. If you're unsure of that, put it in your calculator. You get negative 0.15 D equals 1.8, and then divide both sides. Oh, that's negative 1.8. Divide both sides by negative 0.15. And you get that there are 12 dimes. And if there are 12 dimes, then that means we can take that and plug that back in up here and get how many quarters there are. There are 35 minus 12 quarters, so Q is 23. So there are 12 dimes, 23 quarters. Another kind of problem that comes up a lot is you've got a plane that is flying with the wind. It can travel 1,200 miles in 4 hours, and then when it flies in the opposite direction against the wind, it takes 6 hours to fly the same distance. So find the rate of the plane in still air and the rate of the wind by itself. And we've got a chart to help us here, and also this idea that we should have seen before, hopefully, but even if we haven't, that distance equals rate times time. And so that's true in all cases. Like when you're talking about driving a car and you're talking about driving a certain distance and you need to make it in a certain time, you can plug that in and find the rate, the average rate that you would have to go, and you could figure out, hey, is it possible for me to get there on time or not? This is a real formula. So in this, in here, we're going to fill in our table really quick. We know that we're talking about 1,200 for the distance, and we're actually talking about that both directions, because we're basically talking about a round trip. And then the first time, the trip with the wind, it takes 4 hours. The trip without the wind, or against the wind, is 6. And the concept we have to understand here that comes into play with the rate is that whenever we're flying with the wind, just like when you're walking and the wind is behind you going forward, those things are helping each other. So we would add their rates together. The wind is going to make the plane go faster. If they're going against each other, just like if you are walking against the wind on a really windy day, those fight against each other. So we would subtract those rates. Now, since distance equals rate times time, I can set this up and say, well, distance, which is 1200, equals our rate, which is x plus y, times time. And I can say that that's the one with the wind, and then without the wind, or against the wind, we have x minus y times 6. And so your first inclination here might be to go ahead and distribute, and that would be fine, but it'll actually be easier if, since we're multiplying by 4 on the first one, let's divide by 4 on both sides. And that gives us 300 equals x plus y. Then on the second one, we can divide by 6 to start off. Instead of distributing it, divide by 6 on both sides. So 200 equals x minus y. And what that does is it sets up a really easy elimination problem. All we have to do is add these equations together as they are. So 500 equals x plus x, which is 2x. Divide by 2 on both sides, and you get 250 equals x. So that's the speed with the wind. That's the speed of the plane, because x equals the speed of the plane. So the plane is going 250 miles per hour. Then we can plug it back in. I'd plug it in right here personally and say, okay, well 300 has to equal x, which is 250, plus y, and subtract 250 from both sides. So y equals 50. So the wind is going 50 miles per hour, which is actually pretty fast. There you go.